Hi everyone, welcome to our YouTube channel Hayagreev Foundation. Now I am going to discuss about the topic Cartesian sign convention for reflection by spherical mirror. It is the part of light. So this sign convention is very important to solve the problem or derive the mirror equation or magnification formula in higher classes. First point of sign convention is the object we should keep left side of the mirror, either concave or convex mirror. Object always we should keep leftwards of the mirror. So that nothing but negative x-axis we need to keep the object. So this is first point. Second point, all the distances we should measure from pole of the mirror. Pole is nothing but geometric center of the mirror. So distances all we should measure from pole of the mirror. This is second point. Next, third point, the distances we are measuring leftwards of the mirror. Mirror leftwards we should take as negative. Negative means that is nothing but a negative x-axis direction. We should use negative. Next point, distance we are measuring towards right side of the mirror is taken as positive, that is nothing but positive x-axis. So next sign convention is the height of the object or height of the image we should measure. So height of the object or height we are measuring upward from the principal axis is taken as positive, downward is taken as negative. Simple way, we know the axis, two axes we are taking. This is x, y axis. So this side is positive, this side is negative. Like word, upward is positive, downward is negative. In simple way, we can measure the height or distance using mirror. In this simple way we can use positive x-axis is nothing but positive, positive y-axis also positive, negative x-axis and negative y-axis we are measuring means that is negative. So Cartesian sign convention. This is nothing but mirror equation or mirror formula. 1 by f equal to 1 by u plus 1 by v. F indicates the focal length of the mirror, u indicates object distance, v indicates image distance. In this formula, any two quantities are known, another quantity we can measure. One small example I am going to give. In a problem, they had given the focal length of the mirror. They used concave mirror. Focal length of convex mirror is 20 cm. Object distance is -10. Then unknown quantity is v, image distance we should measure. Focal length of concave mirror is negative, convex mirror is positive. Object distance is always negative, so we need to find the image distance. Using this formula, we are going to find 1 by f equal to 1 by u plus 1 by v. So 1 by v equal to 1 by f minus 1 by u. F is positive, that is nothing but convex mirror, 20 minus 1 by u value is -10. 1 by v equal to 1 by 20, minus into minus is plus 1 by 10. LCM we need to take, that is nothing but 20. So here 1 plus 2. 1 by v equal to 1 plus 2. So 1 by v equal to 3 by 20. So v is nothing but 20 divided by 3 centimeter. So any two quantities, either object and image distance we known means we can find focal length of the mirror. Either by seeing the focal length we can find either the mirror is convex or mirror is concave. Focal length of concave mirror is negative, focal length of convex mirror is positive. So here I used convex mirror, so I used positive focal length, f equal to 20 cm. As we know, image formed by convex mirror is always erect and virtual image. That reason we are getting image distance is positive. Now I am going to explain about magnification of mirror. Either plane mirror or concave mirror or convex mirror, we can find magnification. Maybe we are standing in front of plane mirror, same size of our image we can get from mirror. So linear magnification of plane mirror is always 1. Important question only, what is the linear magnification of plane mirror? That is 1. In the case of convex mirror, image is always very small. So magnification of convex mirror is always less than 1. In concave mirror, the position of the object will decide the position of the image and size of the image. So here in concave mirror, the magnification value will vary. If concave mirror object we are keeping at center of curvature means image also we are going to get in center of curvature, same size of image we are going to get. So at the place of center of curvature, the magnification of concave mirror is -1. So what is meant by magnification of mirror? That is nothing but height of the image. It is the ratio. Divide means we need to use the word ratio. The ratio of height of the image to the height of the object is nothing but magnification of mirror. So magnification of mirror m equal to h dash divided by h. H dash will indicate the height of the image. H will indicate the height of the object. So one more formula we are using, minus v by u. V image distance, u indicates object distance. So example, refraction we can see in our home also. In bucket of water we filled and we are seeing the bottom of the bucket, it is appearing little raised. That is due to refraction of light. Bottom of the swimming pool also appear little rise. If the light ray falling from one medium to another medium, the direction of light is going to change. So why the direction of light is changing means when light is traveling from one medium to another medium, velocity of light is going to change. If velocity of light is very high in vacuum, then next in air. If the velocity of light is changing from one medium to another medium, velocity of light completely depends on the refractive index of the medium. So here refraction is nothing but it is defined as the position of or direction of light ray changing when light ray is going to travel from one medium to another medium, or one more we can use, the path of the light ray is going to change when light ray is going to travel from one medium to another medium. So that phenomenon is called refraction of light. We know reflection, it will incident ray and reflected ray both also travel in the same medium, but in refraction incident ray and refracted ray both also traveling in two different medium. For example, if transparent water bottle, the water bottle inside, the light ray is going to get refracted. Light is traveling from one medium to another medium, speed is going to change, wavelength is going to change, and direction. These three properties are going to change when light ray traveling from one medium to another medium. But one thing is cannot change, that is nothing but energy of the light. Energy of the light doesn't change when light ray is going to travel from one medium to another medium. Why light energy is not changing means the energy of light ray completely depends on frequency of the radiation. So frequency of the radiation also does not change when light ray gets refracted. So three properties will change, direction of light will change, wavelength of light will change, and path of the light also going to change when the light ray undergoes refraction. But energy and frequency of light ray doesn't change when the light is going from one medium to another medium. Now I am going to explain about the refraction of light ray. In first medium, the light is entering, so this is nothing but incident ray. When it will touch the surface between the two media, the light ray is going to get refracted. So this ray is called refracted ray. The incident ray, the refracted ray, at the point of incidence we should draw the normal. Normal in the sense always we should draw perpendicular, as I thought earlier in laws of reflection. This is incident ray, refracted ray, this is point of incidence and normal. The angle between incident ray and normal is called angle of incidence. It is represented by the symbol small I. The angle between refracted ray and normal is called angle of refraction. It is represented by the symbol small r. So this one we are going to use to derive the laws of refraction. So first I am going to explain about laws of refraction. First law, the incident ray, the refracted ray, normal at the point of incidence all lie in the same plane. So this is first law. Second law is the ratio of sine of the angle of incidence to the sine of the angle of refraction is constant between any two media. So this second law, one more name is Snell's law. So define Snell's law, even they may ask. That is nothing but Snell's law is nothing but it is the ratio of sine of the angle of incidence to the sine of the angle of refraction is constant between any two media. So now I am going to explain about refraction of light through glass slab. So we need to take a glass slab. We need to keep a plain paper. First we need to draw the boundary of the glass slab. Boundary of the glass slab, we need to mention A, B, C, D. We need to use two pins in the side of AB. We need to place P1 and P2 through. We have to see these two pins through the face CD. So in the direction of CD, the images of these two pins, we need to keep two more pins, that is P1 dash and P2 dash. So P1 dash will be the image of the pin P1 and P2 dash will be the image of the pin P2. After removing the glass slab and the pins, now we need to join P1, P2. It will indicate nothing but the incident ray. So this P1 dash and P2 dash we are joining means this we are going to get emergent ray. Now the P1, P2 is nothing but incident ray. It will touch the glass slab in the face AB. P1 dash and P2 dash will emerge from the face CD. So this is called emergent ray. After removing this incident ray and the emergent ray we are joining means we are going to get a refracted ray. So light is traveling from air medium to glass medium. The direction of light is going to change. Again the light is going to travel from glass medium to air medium. Now even the direction of light ray is going to change. First ray is incident ray, refracted ray, and this is emergent ray. So incident ray, angle of incident I1, angle of refraction R1 we need to mention. So for this face, the face CD, this is the incident ray, this is the refracted ray. So this angle is I2 and angle of refraction we need to mention R2. After we are seeing very carefully means the direction of incident ray and emergent ray both also traveling in parallel way, but it is shifting little bit backwards. If without glass slab the light ray want to travel straight, if we place the glass slab, after the ray emerge out from the glass slab is delayed little bit back. So this we will call lateral shift. Now I am going to explain about refractive index. So define refractive index means it is the ratio of sine of the angle of incidence to the sine of the angle of refraction is called refractive index. It is represented by the symbol small n. Next, there are two types of refractive index. One is absolute refractive index, another one is relative refractive index. So in that, absolute refractive index is defined as the ratio of speed of light in vacuum to the speed of light in particular medium. N equal to formula C divided by V. Speed of light in vacuum we know V 3 into 10 power 8 meter per second. Speed of light in particular medium will change from one medium to another medium. So next, absolute refractive index we have to represent by N21, that means refractive index of second medium with respect to first medium. Same way we can use N12 also. So N12 means refractive index of first medium with respect to the second medium. So here I used N21, that is nothing but the ratio of speed of light in medium 1 to the speed of light in medium 2. Otherwise velocity of light in first medium to the velocity of light in second medium is called relative refractive index. So now refraction through lens I am going to explain. First we want to learn what is lens. Lens is an optical medium bound by at least one curved surface. In some lenses both sides also curved. In some kind of lenses one surface is curved, one is plane. that is called lens. There are two kind of lens are there. First one is convex lens, another one is concave lens. So in convex lens, center of the lens become thicker, edges become thinner. That is called convex lens. Same opposite we need to say for concave lens. Middle is thin, edges is thicker. That is called concave lens. One more name of convex lens is converging lens. One more name of concave lens is diverging lens. So convex lens we know, normally we will play with paper. So we have to take convex lens and a small piece of paper. We need to focus through the sun. Then a small dot points we are going to, small very bright dot points we are going to get on paper. We will keep continuous for some time. This paper is going to catch the fire. That is nothing but a convex lens. In that small bright spot is nothing but the image of sun. Why the paper is catching fire means this light ray falls on convex lens, all it is going to converge at one point. So due to high intensity, the paper is going to catch the fire. Convex lens is converging lens, concave lens is diverging lens. So this is the symbol for convex lens. This is the symbol for concave lens. So in convex lens, middle is thicker, edges are thin. In concave lens, middle is thin, edges are thick. So this one more name is biconvex lens. Why we are saying biconvex lens? Both side also curved. So two sides curved means 2 means bi. So both side curved. So this is called biconvex lens. This also called biconcave lens. Here one side is plain, one side is bulged. This is called plano-convex lens. Same wise, this is called plano-concave lens. So different types of concave or convex lens also we are using. So convex lens is a part of two spherical surfaces. These two spherical surfaces or spheres are made up of glass. In this part we are going to get in the form of convex lens. So first curved surface center is this one. So center of curvature we have to mention C1. For next curved surface center is C2. So center of curvature we need to mention C2. Each and every lens there are two center of curvatures. Likewise concave lens. Concave lens also a part of two spherical surfaces. For first curved surface, this is center of curvature. For this we need to mention C1. Next curved surface center is C2. Next, the geometric center of the lens is called optic center of the lens. So define optic center of the lens is nothing but geometric center of lens is called optic center. It is represented by the symbol O. Each and every lens, concave lens or convex lens, geometric center will be, that is called optic center. So next, center of curvature. Center of curvature is represented by the symbol capital C. Each lens having two center of curvature. If one is plane, the center of curvature is like infinity. Center of curvature, the spherical surface is a part of the lens is a part of two spherical surface. In these two spherical surfaces having center, that are called center of curvatures. Each lens, convex or concave lens, having two center of curvature. Next is principal axis. What is meant by principal axis means the imaginary line passing through the center of curvatures are called principal axis. So you can extend the line both the directions. Imaginary line passing through the center of curvatures are called principal axis. So next is radius of curvature represented by the symbol capital R. So each lens having two radius of curvature, that is nothing but the distance between optic center and center of curvature is called radius of curvature. Each lens having two radius of curvature. For convex lens R2, this is R1. For concave lens, first one is R1, next one is R2.
ನಾವು ಮಾಡ್ತಾ ಇರೋ ವಿಡಿಯೋಗಳು ನಿಮ್ಗೆ ಇಷ್ಟ ಆಗಿದ್ದಲ್ಲಿ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಪಕ್ಕದಲ್ಲಿರೋ ಬೆಲ್ ಐಕನನ್ನು ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ನಾವು ಮಾಡೋ ವಿಡಿಯೋಗಳ ನೋಟಿಫಿಕೇಶನ್ ನಿಮಗೆ ಮೊದಲು ಬರ್ತದೆ. ಯಾವುದೇ ರೀತಿ ಸಂದೇಹಗಳಿದ್ರೆ ಕಮೆಂಟ್ ಸೆಕ್ಷನಲ್ಲಿ ತಿಳಿಸಿ. ಹಾಗೆ ಈ ತರಗತಿಗಳು ಹೆಚ್ಚಿನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ತಲುಪುವಂತೆ ಶೇರ್ ಮಾಡಿ.